this topic is not in your book. You will have a problem or two on the section 1 homework that asks you to solve systems of nonlinear equations. Here's a system that looks a lot like the ones we've been doing, except that it has an x squared. That means it's not linear. Now we can still use the substitution method on this. Step 1 of the substitution method is to take either of those two equations and solve for one of the variables. If we take the bottom equation, solve for y, we can then take the other equation and in place of the y, put what we just found. And then finish solving using the distributive property, and then subtracting 10 from both sides, we get the quadratic equation. We can solve the quadratic equation by factoring or by using the quadratic formula. However, just like in solving the linear equations, once we get the value of x, we still have to have the value of y. For each one of these values of x, there needs to be a value of y. We can take any equation that we have and substitute a 4 for x. The simplest one would be the one we got here in step 1. So substituting a 4 for x, we get the value of y. And substituting a 2 for x, we get the value of y. Now we want to make sure we get these communicated properly. The first point would be 4, 3, and the second one would be 2, negative 3. Now here's the graphs of those two things, so you can see what it is that we just did and how it relates to the graphs. The first equation is nothing more than a parabola shifted down 5 units. And the second one is a straight line. The places where the two graphs intersect are the two answers that we just found. Now this could be a useful tool for solving systems of equations if we can draw the graphs and find out where they intersect. The substitution method on this system would look like this. If we tried taking the equation in the top, since it's already solved for y, and substituting it into the second one, we get something that looks like this. Now that is not going to be easy to solve, although we did do some of these back in a previous chapter. The idea is there's a better substitution. Look at this. If we take the top equation and rearrange it some so that we have solved for the x squared instead of the y, we can take the other equation and replace the x squared with y minus 3. And what we have is now a quadratic equation. Put it in standard form, use our quadratic formula. And just like with the previous problem, for each one of these values, we need to find out what is the x. So taking the 3 and plugging it in, we get an x of 0. Now taking negative 4 and substituting it, x squared equals negative 7 means x would be the square root of negative 7, which is not a real number. There's no answer to that. And so the only point of intersection for those would be 0, 3. Here are the graphs of those. The first one is the parabola, shifted up 3 units. The second one is a circle with a radius of 3. And the point that we just found where they intersect is the 0, 3.